in order to plot the points, you have to put them in L1 and L2, guys. So go to Stat, Edit. I need to clear the list. So I'm going to clear the list right here. And clear, enter. I'm going to clear L2. That's from, and then enter. Oh, I didn't hit clear. Clear and enter. Okay. Let's enter the X values. So you always enter the X values in L1. Let's put them there. 5.2, 7.3. I can't see if you're doing this, guys. If I was in the classroom, I would be asking you to participate with me. But it is in your best interest, just to participate, because you're going to need to do this later. So do it now. While I'm here, I can support you if you need any help. That's L1. Let's go to L2 and put the Y values. These are ordered pairs, guys. Like 5.2 is related to 3.3. 7.3 is related with 5.9. I'm not going to ask you to plot those by hands. It will be hard to plot them by hands because they have decimals. But you're going to see technology is very nice. 6.1, we have 4. Then 7.1. Then 3.6. Then 6.1. Okay. I would like you all to do this now. You're just going to do it once for this chapter. You press on the second key, you press on Y equals, and you press enter. And I like it to turn the statistics plot 1 on. So that's going to be on right here. And there's nothing else. You just quit. I need the X list to be in L1. It is in L1. I need the Y list to be in L2. And I need the scatter plot, which is selected by default for me. It's right there, guys. So we're good. And I would like you to hit zoom now. And then number 9, zoom statistics. And press enter. Don't worry about this line. This is from before. Let me just delete it. There you go. You can see the scatter plot. Have some of you done that on your calculator, guys? And if you did, can you just confirm that you were able to see the same thing right there?
Yes.
Okay, good. I know the overwhelming majority of you are quiet. Just a few students participate. I'm aware of that, but I'm assuming, guys, that you're doing what I'm asking you to do. And I hold you not just responsible for that. You need to do the work while I'm doing it. If you were in the classroom, I would try to enforce this one way or another to participate with me. That's very, very important, guys, because you do it once, trust me, when you go back and review your work, it's not going to be it's going to be easy. So again, let me explain. A student asked me to explain one more time. I'm happy to do that. So look what you do. First of all, you go to Stat, Edit, and you enter L1 and L2 in there. That's very, very important. You need to feed in the calculator with the data in L1 and L2. X values usually go to L1, the independent variable, and Y value go to L2, which is the dependent variable. After that, look what you do. You press the second key, and it's all in the handout. So if you forget them, I listed them, just in details in the handout, and you can watch this video. And then you press Y equals, you press enter, you make sure that on is selected right there, and you make sure that the first one is selected, which is a scatter plot, and that's it. And now to sketch the scatter plot, you just press the zoom and then number 9. There you go. Do you guys agree with me that there is a positive linear relationship between the X and Y values? Does it seem like it? Well, I think you should agree. It does seem like it. Look, they seem to be connected with the line like this. As X values increase, the Y values increase as well. Okay. Now, what would be the line of best fit here, guys? The line of best fit probably would be a line something like this. Let me just show you right here. And as I told you, I'm not going to ask you to find this equation by line by hand, which is very difficult because you need to know the line that fits, not just all of them. The good news is the calculator can do that for us. And let me show you how we're going to do this on the calculator. But before we do that, there is a setup on your the calculator that I like everybody to do it, and you do it once and for all until the end of the semester. If you reset your calculator for whatever reason, I would like you to go back, just and redo, and all the information are in the handout as well. So here is what I like everybody to do now for me. So you can quit. I'm going to quit right here, second and quit. I would like you to press the second key and then the 0 key, which open a catalog. So second followed by a 0, and you should see this. And I like you to scroll down, guys, with this key until you see the word diagnostic on. See all those functions built into your calculator? Too many.
This won't change anything if we're using the calculator to do
No, no,
or anything.
no, it's just an added feature.
Okay.
That's a good question, observation. No, it doesn't. Just an added feature for this chapter that we need. We need badly, because that's going to help us a lot. All right, I am at a diagnostic on, guys. Press enter. There's the enter key right here, twice, until it says done. It is critical, guys, that you do this. If you don't do it now, you better do it later, because this is gonna add some features to the calculator that we need for this chapter. All right. And if you reset your calculator, you just go back to second and number 0 and go to diagnostic on and turn it on again. So it is done for me here. You see? All right. Let me show you now how we're going to find the equation of the line and something else along the way. So we already have the data, and this is pretty much the chapter, guys. After I do this, there is one little thing about hypothesis testing, and I'll be done with that chapter. But you need, just to learn the setup using the TI-84 in order to answer most of the questions in this chapter. I would like you to go to Stat, Calc, and without me telling you guys where we should go, where do you think we should go given what I've been talking about in this chapter? Which number? There are probably 2 numbers that you should pick for me.
4.
4, why? Why 4?
Because it has that x plus b.
And it has linear regression. LIN means linear regression. Okay, good. I got another 4. And there is another one, which is linear regression A plus BX. It's the same thing. We're just going to use number 4. Number 4, guys, take a note of this. This is the highlight of this chapter. Okay. Let's click on it. I'm going to go very slow. I'll repeat, guys, if you want me to repeat. And then if your calculator doesn't show this screen, guys, just press enter and you're done. But mine is showing this screen. It wants me to confirm. My X list is an L1, yes. My Y list is an L2, yes. Frequency list, don't touch it. Just calculate. Enter. Oh, let's write down what we have here. It's going to be summarize half of that chapter right here. So I'm just going to copy what I see on the screen. So I'm going to write y equals ax plus b. I'm going to write the a value, which is 1.26. The b value, which is negative 3.30, rounded to 2 decimal places. And I'm going to put two values that I see on the calculator. One is called r squared, and one is called r. All right, that's what the
We always use 2 decimal places for these?
Yeah, I'm just doing 2 decimals.
Okay.
I usually tell you how many decimal places you should use, but I'm just using 2 decimals. Okay, guys, here is one thing I'd like you to notice. If you replace a 1.26 here and you put the b by its value, you will get this equation. Watch. 1.26x minus 3.30. This is the equation of the line. This is the equation of the line of best fit, guys. The 1.26 is the slope of the line. It's a positive. That means your line is going to be pointing up as you move to the right. And the negative 3.3, guys, is the y-intercept. So what the calculator did for me, I didn't have to figure out how to write the equation of the line. The calculator gave me the equation of the line. It is called the line of best fit, or the regression line. This is the line where most of the points belong to. And I'm going to sketch this line, guys, in a second and show you that, yes, it is indeed a line of best fit. Probably not all the points are going to be on the line, but they're going to be so close to the line that this line will be called the line of best fit. So let me go back to my calculator and show you how to sketch this line. So remember the equation, guys, 1.26x minus 3.30. And how did I do it again? All I did, I replaced a by its value and b by its value. And the calculator did give me a, it gave me the slope, and it gave me the y-intercept. The one who wrote this program didn't call the slope m, he decided to call it a, so we're just using a, but a is the slope, which is the m here. Okay, guys, let's do this together. To sketch the line, press Y and just enter 1.26x. Watch. Let me show you, project the entire calculator. 1.26x. Here's the x right here, guys. Minus, here's the minus right here. 3.3.
But wasn't it negative 3.3?
Yes. Well,
So
the plus negative, which is minus.
Put
Yeah,
in the
that's
negative
fine.
as well.
Yeah, you can put plus negative, or you just go put minus. That's fine. Yeah, if you are in the middle of the sentence, the middle of the expression, it doesn't matter whether you use the negative sign or the minus. But if you are at the beginning, you must use a negative. So 1.26x minus 3.3. And let me hit the graph, guys. Watch and see what's going to happen. Did you see the line of best fit? That is the line of best fit. It misses some of the points, but it's impossible to draw one line that captures all the points, because it's not a perfect, linear relationship. It is a very strong linear relationship between the x and y values, but it's not perfect. And in real life, guys, you will never get anything that's near perfect. It's always going to be situations where the linear relationship is not perfect between two values. So this is called the line of best fits. Some of the points belong to the line. The other ones are very close to it, but that's what we call the equation of the line of best fit. So one of the questions you will be asked in section 9.1, You will be given two data sets, X and Y values, and you'll be asked to find the equation of the line. This is how you do the equation of the line. You put the data X values in L1, the Y values in L2, and then you go to stat, again, calc, and then number 4, and then press enter, and then you hit calculate, enter, and here you go. That's the equation of the line. Now, the next question, guys, you might want to ask me, what does R mean? When you did the diagnostic on the R value is displayed now on the screen as a result of this action. And let me tell you what R means. R is very, very important. Let me tell you how you interpret R. Because usually the first question also in section 9.1, he will ask you to find R and ask you to interpret its value, its meaning. R is called the sample correlation coefficient. And let me tell you how we use R. If R is very close to 1, do you guys agree with me that 0.97 is close to 1? Yes or no?
Yes.
If R is very close to 1, you can say that the relationship between X and Y is very strong, positive, and linear. So the relationship between X and Y is very strong and positive and linear when R is very close to 1. When R is very close to -1, guys, you can say that the linear relationship is very strong but negative, because it's as X increases, Y decreases. Now, if R is close to 0, we say that the linear relationship is very weak. And I'm going to show you some examples, guys, of R. When R is very close to 1, you will feel that the points belong to a line. When R is close to 0, you will feel it's a mission impossible even to get some of them, just close to a line. And all those informations about R are listed right here. If R is very close to 1, we say that there is strong positive linear correlation between X and Y. If R is very close to -1, we say there is strong negative linear correlation between X and Y. If all the points fall on the line, then R will be exactly 1 or -1. That's perfect. So when R is 1, guys, or -1, you have a perfect linear relationship, all the points on the line. If R is very close to 0, then the linear relationship between X and Y is very weak. We will not calculate R by hand. You can use a calculator to find the value of R. And this is an explanation of how I did the calculator, use catalog, to turn diagnostic on, etc. So if you forget them, guys, you can always refer to this part to get R back. Okay. Look at this, guys. Do you agree that there is a strong negative linear relationship between X and Y? As you notice, as X increases, what happens to Y? Decreases. Can someone guess what would the value of R be here? It has to be negative and close to -1. What would your estimate be? Any guesses?
-1.
No, it's not perfect.
Well, then -9.6.
-0.99 probably, or -0.98. Yes, it will be very, very close to -1, guys. But it's not -1, because if it is -1, you have to be able to put all the points on one line, which is not possible here. What do you think of the next one, guys? It looks like it is very strong, positive linear correlation. And if you have the data values on your calculator, guys, I can tell you your R is going to be very close to 1, probably 0.99 or 0.98. Because for this one, I got -0.97. So imagine for this one where the points are even closer, just to the line. Do you agree, guys? It says here in the answers that there is no correlation. Look, they're scattered all over. I cannot see a relationship here at all. So if you try to calculate R here, it's going to be very close to 0. either from positive side or negative side, no correlation. Correlation means linear relationship between X and Y. Look at this one here, non-linear correlation. We're not interested in this type of relationships. And let's, okay. I'd like you guys now to help me guess the values of R here in this one. And let's see how good are you at guessing. What do you think the value of R here is? That's easy.
1.
1, because all the lines, all the points belong, you know, just to the same line. Look. And I can assure you guys, if you put them on the calculator, try to find R, it's going to be 1. What do you think of this one? It looks like there is a positive linear correlation between X and Y. What's your guess for R? It's less than 1, of course. Any guesses? Don't worry, guys. I'm not going to penalize you if you give me a wrong answer.
0.96.
Okay, 0.96. Any other guesses? Because I'm about to reveal it.
Maybe like 0.8. Yeah.
Oh, you're good. It is 0.81. Just because of these two guys, they're like, you know, seem to be odd. That's caused the R to go a little, but it is a positive. Now the question, when do we say positive? When we say strong positive? If it is like 0.8 and up, we say strong positive. When it is like less than 0.8, 0.7, 0.6, we say positive. And then once you get closer to 0, it becomes a weak relationship. Okay, guys, what do you think it's going to be for this one? Definitely less than that one. It doesn't look like well correlated that one. Any guesses?
0.5.
Okay. I'm going to reveal it. Very close, 0.45. Excellent. Okay, let's go to the second part now. What do you guys think? This is easy here. What is it going to be for this one?
1.
But it's pointing down. So it will be what? -1, correct. What do you guys think it's going to be for this one? It seems like it's very strong relationship, but from the negative side. Any guesses?
Negative 0.98.
Okay, let's see. You're close, negative 0.92. And this one, that looks like not good. Even this is better than that. What do you guys think? Just give me a guess. It has to be a weak value of R. It can't be a strong value of R.
Negative
0.3. Okay, let's check. It was 0.04, almost 0, no correlation. All right, so I hope that this is giving you a feel, guys, of how you can tell by looking at the points, the scatter plot, which we call it the scatter plot. You can tell what the value of R. The good news is your calculator can find R, and then you don't need to guess it. You just use R to tell how strong or how weak the relationship between the two variables. Let's just enforce what we learned. So determine whether there is a perfect positive linear correlation, strong positive, perfect negative, strong negative, or no linear correlation. What would you say for this? Which one?
Strong negative.
Strong negative. 10.
No linear.
No linear, I agree. 11. It doesn't look linear. So he's asking you to choose from those. So no linear. What about 12, guys?
Perfect linear.
Perfect linear. Is it perfect positive or perfect negative?
Perfect positive.
Positive.
Exactly. And if I ask you guys to say what R is here, you can tell me, Mr. Bazzi, I know for sure it's going to be 1. But here, you will tell me it is negative 0.9 something, but you wouldn't be sure because it's not perfect. I wouldn't be able to tell exactly what the value is.